rule, so hopefully it can help with it. The beginning here is just going to be a lot of derivative work, so please excuse my handwriting and I'll do my best to be thorough. So when we're dealing here with f of n, the predation rate, it's important to notice that you were told that a and k are both positive constants. Both of those are going to be important here in a second. But that'll make this derivative a little easier. Still, we have a variable, our variable in the numerator and denominator, so we're going to need the quotient rule. So remember, the quotient rule has several steps. I'm going to go through all of them. So to take the derivative here, f prime of n, the first step of our quotient rule is we're going to take the denominator, so all of that, k squared plus n squared, and multiply by the derivative of the numerator. In this case, since a is a constant, n is our variable, the derivative of that n will be 1, and we'll just be left with a constant, so times a. A is the derivative of the entire numerator. The rest of our quotient rule, the rest of the numerator here, so we're going to subtract. Now we're going to do the numerator, so a times n, times the derivative of the denominator. So again, down here, the k squared, the k is a constant, so the derivative of that entire thing will just be 0. And then plus n squared, n is a variable, so the derivative of n squared will be 2n. And that's not even the entire quotient rule, because now we need to put all of that over the denominator squared. So this entire thing, k squared plus n squared, and all of that gets squared. So this looks pretty funky, but luckily there's a couple tricks here that are going to help us to ignore part of it. But before we do that, we're going to clean this up a little bit. So up here at the top, I'm going to distribute and do some multiplication. So if I distribute this a into the parentheses, I'll end up with a k squared plus a n squared, and then minus 2a n squared. And when I do that, I'm always pulling constants out to the front. So in that last term, 2 and a are both constants. I pulled those out front. And then on the bottom, I'm actually going to leave this thing the exact way it is, and you'll see why in a second. I have enough practice to know that multiplying, distributing is not going to help me at all. So for now, I'm just going to leave this k squared plus n squared, and then squared. There's still a little bit of cleaning up we can do on top here, so this will all be equal to, notice that the second and third terms are like terms. We have an an squared and an an squared. I have one of them here and then minus 2. So I'm going to be left with ak squared, and then 1 minus 2 will be minus 1 an squared, or just minus an squared. And then again, I'm going to leave that entire denominator the exact same. So k squared plus n squared, all quantity squared. All right, so all of that was my derivative. We can actually do one more thing. You don't have to, but it'll make it a little easier. So I'm actually going to factor the a out on top here and rewrite this as a times k squared minus n squared. That step is not entirely necessary. If you don't want to do it, it doesn't change a whole lot. I think it's just a little easier to see what we're about to do. Denominator stays the exact same again. And that's because all of that was just to get the derivative. Now we need to go back to what we're actually being asked. It said for f prime of n, find f prime of n, and determine when that per capita predation rate, f of n, is increasing or decreasing. To do that, the easiest way to figure out when a function is increasing or decreasing, a function is increasing when its derivative, its rate of change, so in this case f prime of n, is positive. If the rate of change is positive, the function is increasing, it's going up. The function is decreasing when that same derivative, f prime of n in this case, is negative. So if f prime of n was -5, for example, at that point, the function would be decreasing. So we found this derivative just so now we can figure out, okay, when is that thing negative and when is it positive? And this is where it's really helpful to do what's called a sign test. You figure out When am I getting positive numbers? When am I getting negative numbers? So that's what we're going to do for the rest of this video. The first thing you need to know, I'm just realizing I missed a squared here on my derivative. The first thing you need to know is where your function hits 0, if it does at all. Because we're going to be looking for where the function's positive, so we can find the increasing values, where the derivative is positive and where the derivative is negative. So it would help to start out and figure out where it's 0, where is it neither negative or positive. So to do that, I'm going to take this entire derivative we found here, and I'm going to set that whole thing equal to 0. So the question now is, our variable n, what should that variable be so that we get 0 out of this whole thing? What could we plug in for n to get 0? Well, here's a helpful trick. Look at the denominator here. This is why I actually left this as it was. Think about this. What kind of values are you going to get out of this denominator? Keeping in mind that k and a were both positive numbers. Well, notice that every single thing down there is squared. What do you get when you square a positive or a square number? You always get a positive. Doesn't matter what you square. If you square a positive or a negative, you end up with a positive. And since we know nothing can be, or k can't be 0, that means this entire thing here, that entire denominator, has got to be a positive number. No matter what you plug in for n, you're always going to end up with a positive number. And the reason I cross that out is because it really doesn't matter anymore. All we care about is what we end up with, positive, negative, or 0. And dividing by a positive number is never going to change that. It's never going to impact what we end up with. So all we really need to care about then is this numerator. We need to know when is a times k squared, that's a crappy a, k squared minus n squared, when is that equal to 0? Well, we can solve this pretty easily. If we divide by a on both sides, which is just a positive number, 0 divided by a will still be 0. So we'll end up with k squared minus n squared equals 0. We can add n squared on both sides. That'll get k squared equals n squared. And then to eliminate these exponents, we can do the square root of both sides. So k is equal to n. Now remember what we were trying to figure out. We were trying to figure out what number would I plug in for n to get 0 from my derivative. And it just so happens that that number would be k. I don't know what that is. I know it's bigger than 0, but I know it's k. I'm going to put that right here in the middle. That's my number that would give me 0 from the derivative. I'm not plugging in 0. That's not what k is. But if I plugged in k, I would get the 0 out that I'm looking for. So now I still want to know, when am I getting not 0, but when am I getting numbers that are positive or negative? Well, what we're going to do is we're going to test. That's where this test piece comes in. We have 2 pieces that we can divide our number line into. I know 0 is somewhere down here because I know k is bigger than 0, but I need to test all of these numbers on the left-hand side. I need to test numbers that are less than k, and I also need to test numbers that are bigger than k to see whether I'm getting positive or negative numbers. Okay, so I still run into a problem because I don't know what k is, right? If I knew k was 2, a bigger number would be 5, a smaller number would be 1. But I don't know what those numbers are. But one more trick that I can use here. I can still use the relationship between k and n. Remember what we said a second ago, the denominator, all this k squared plus n squared quantity squared crap, that's basically out of the equation because it's always going to be positive. It doesn't impact anything. So all I really want to know is when can I get this piece equal to 0? And in fact, since a is always positive as well, let's get rid of it. Multiplying a number times a positive number, doesn't matter what that positive number is, it's not going to change the fact that it's positive. So ultimately, I want to know, right, I have k squared minus n squared, And I don't want that to be equal to 0 anymore. I want to know when is that greater than 0 and when is it going to be less than 0. Because when that's greater than 0, I'm going to end up with increasing function. My derivative will be positive. When it's less than 0, my derivative will be negative and my function will be decreasing. So just think about how they need to compare, how k and n need to compare to get these two things. What would I need to know about k and n for the result to be 0? Well, the only way, or for the result to be positive, the only way that's going to happen is if k is bigger than n, right? Let's say k is 5 and n is 3. Then that means we're going to end up with a positive number bigger than 0 when you plug that in. So that means over here, right, here's my k. If n is over here, if n is less than that, any of these numbers, doesn't matter, we're going to end up with positive results. And I'm going to put a plus there to help me remember that. In the other case, if I pick a number bigger than k, if n is bigger than k, then the second term here is going to be much bigger. And when we subtract that, we're going to get a negative number. And that'll happen for any of these numbers above k. All of those will return a negative. So all of that work just to bring this down to 2 intervals. We have this left-hand side where we get positive values for the derivative. We have the right-hand side where we get negative values for the derivative. And that gives us these 2 answers here. So now we just need to write our final intervals. Our increasing rate will happen when the derivative is positive. So that's these positive values down here. Our interval can't go less than 0, right? We can't have less than 0% worms. So we're going to start the interval at 0, and it's going to go up until k. At k, our interval goes from positive derivative values to negative. And that's where we'll pick up the second interval. Starting at k and going on, our derivative values are negative, so the function, our predation rate, will be decreasing. So that'll start at k, and it'll end. You might be tempted to write infinity here, because that's what happens in a lot of calculus problems, but keep in mind the context. A percentage density shouldn't be over 100, so I'm going to put k to 100. Depending on how they're considering this density, potentially they could make an argument for going above 100, but for now, I'm going to leave that as k to 100. So it's a really lengthy problem, a lot involved, but this is a very common type of problem, especially if you end up taking the AP Calculus exam. Almost certainly is going to be a type of problem like this on here. So remember, if you're trying to figure out when a derivative is positive or negative, or sorry, when a function is increasing or decreasing, you can figure out when the derivative is positive or negative using a sign test. So I hope that helped, and I'll see you next time.